if it's a flat plate which is infinitely long, yeah, infinitely long sheet. Of course, it's hypothetical. In reality, it is not there. But most of the problems in reality, if the plate is too long, can be approximated to be infinite. It's a fairly valid approximation. If you were to see an infinite sheet of certain charge distribution of rho s coulomb per meter square, that many coulombs per unit area, your limit a tends to infinity, that expression is going to go to zero, which means this term and this term goes off to zero. It reduces. The expression nicely reduces to minus rho s over 2 epsilon naught and plus rho s over 2 epsilon naught for h greater than 0. So that means I have an infinite plate. By infinite, I can write it like this. That means it's going on forever. So it's all plus, 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 plus charges, which are all uniformly distributed. Clearly, if I take a point charge here, I bring in a plus one charge there, it's obviously going to be pushed up. So it's going to have a direction in this direction here. If for every charge that is equidistant from this point, for example, if I have a charge from this point and a charge from this point, the electric field due to this is going to be this direction, and the electric field due to this guy is going to be in this direction. If I were to add these two vectors, the x components, if I were to call this to be my x component and this is my z axis, clearly my x components will cancel each other. This guy will cancel this guy. So for every point that is equidistant from the center to the left or to the right, the x components will get cancelled off and you are left with only the so-called z component. You're only left with the so-called z component. A typo here, there must be a z hat here and a z hat here, yeah, because electric field is a vector. But more interestingly, what happens is, regardless of at what height you are from the plate, this was our h, the value is going to be always 2 times rho s over 2 epsilon naught, regardless of whether you are at h or 2h or 3h or 4h. Why so? Because this plate is infinitely long, yeah? So it doesn't matter how high you are. You could be even at a infinitely long height. Because the plate is infinitely long, the approximation tells you physically that, hey, even here it's going to be rho s over 2 epsilon naught. So that kind of makes sense. But how about when h is less than 0? It's again the same magnitude, but the direction is going to be in the negative z hat direction, rho s over 2 epsilon naught.